Vertical and horizontal shifts of graph, College Algebra, Chapter 2, Section 2. The vertical shifting of a graph. If c is greater than 0, then the graph of y equals f of x plus c is obtained by shifting the graph of y equals f of x upward a distance of c units. The graph of y equals f of x minus c is obtained by shifting the graph downward a distance of c units. And here you have this illustrated. We have done this before. We've done it both in Algebra 2 and Algebra 3. When you add a number to the function, it's going to shift it up and down. A positive number will shift it up, and a negative will shift it down. Let's look at this example to give the equation of each function graphed. Remember, this is an absolute value equation. Absolute values are typically centered at 0, 0. So these two have both been shifted. Pause the recording to try the problem and resume the recording to check your answer. Okay, the first one on the left has obviously been shifted down 2, so it will be the absolute value of x minus 2. And the one on the right has been shifted up 1 unit, so we have absolute value of x plus 1. We can also translate graphs horizontally. Horizontal translation occurs when you have a number added or subtracted directly to the x in the function. And the direction works kind of the opposite of what you might think. When you have f of x minus c, the graph is going to shift to the right. If you have f of x plus c, it's going to shift to the left. Note the difference in the vertical translation and the horizontal. Here, the number is added or subtracted directly to the x and not at the end of the function. Here we have a couple of examples of how that works. Let's try an example of a horizontal shift. Again, we have two absolute values, and remember, they're typically centered at 0, 0. Pause the recording to attempt the problem and resume the recording to check your answer. The one on the left, the graph on the left, has been shifted 4 units to the right. And remember, these work the opposite way you might think, so that means we're going to subtract 4 from x. Notice that the 4 is in the absolute value with the x. When we shifted vertically, it was outside the absolute value. The one on the right is being shifted 2 to the left, which means we're going to add 2 inside the absolute value. Let's try another example. Describe how the graph of y equals x plus 2, absolute value, minus 6, would be obtained by translating the graph of y equals absolute value of x, and then sketch them. Pause the recording to attempt the problem and resume the recording to check your answer. Okay, the function is being shifted 2 units to the left and 6 down. So the graph is going to change from decreasing to increasing at negative 2, 6. In other words, negative 2, 6 becomes our new middle point, our new important point. And there's the graph. Now, shifting can affect the domain and the range of a graph. So, give the domain and range of this function. Pause the recording to try it. Resume the recording to check your answer. To get this graph, we need to take the graph of y equals x squared and move it 1 right and 2 up. Now, the domain of a square function is all real numbers, and that's not going to change. However, if you remember, the range of y equals x squared is 0 to infinity. We've now moved the bottom point of that graph where it turns the corner from 0, 0 to the point 1, 2. So now 2 is the new lowest value for the range, and the range becomes 2 to infinity. And you could see on the graph how the lowest point is indeed at y equals 2. Now let's practice using an equation. The number of monthly active Facebook users, F in millions from 2009 to 2013, is given by f of x equals 233x plus 200, where x is the number of years after 2009. Your task is to evaluate f of 2 and interpret it, which means tell what that means. Don't just give the number. Use the formula to write an equation that gives the number of monthly active Facebook users in millions during the actual year x. So instead of the years after 2009, we're going to change the equation so that x is the actual year. Then you're going to refer to that and find y when x is 2011 and interpret the result. After that, use the equation that you came up with in B to determine the year when Facebook reached 1 billion monthly active users. Pause the recording to try this out and resume the recording to check your answers. So f of 2, putting in 2 for x, we get 666. So in 2011, 666. Okay, because 2009 corresponds to 0 in the graph, what we're going to do is shift the graph 2009 units to the right. In other words, we're going to replace x with x minus 2009. And then we will simplify, and that becomes our new formula. Now we're going to go back to that equation we just wrote, and we are going to figure out what y is when x is 2011. And we get the same answer that we got for A, which shouldn't surprise us. All we did was shift it and change the conditions. D, we're going to figure out when is y going to equal 1 billion. And by the way, we're using 1,000 because, remember, the number y is in terms of millions, so 1,000 million is 1 billion. So we're solving for x, and we get 2012.4, so sometime during 2012. All right, the rest is classwork. Give the problems a try, pause the recording to do it, and then resume the recording to check your answers. Do this for the rest of the recording.